Hey guys, this is your introductory to kinematics. This is basically the foundational formulas for all physics. Okay. This is our traditional velocity formula. This is acceleration, and these two will give me some sort of displacement. Okay, and I signify that displacement as a delta D. Delta meaning change in, and D meaning distance or some sort of ground that's covered. We'll get into distance and displacement. They're a little bit different from each other, but for purposes right now, this is a change in displacement. Okay? Now let's talk about this real quick. Your main variables, I know that V is velocity. My D is some form of a distance. Little t always signifies time, because in physics we're always looking at some space and time. And of course, A stands for acceleration. So this is technically, it's a change in velocity over a change in time, which we write it out to look like this. So my V of F is nothing but telling me how fast was it going at the final point in time. So that V of F stands for final velocity. R, the V of I, it stands for how fast was it going at the beginning of its time. Okay? So that's what those two variables stand for. You'll sometimes see this also represented as what they call V of naught. It's just a V with a little zero down there. That V naught, or V of naught, all it is, hey, where was that object at the time it started moving? It's the same thing. And if in that situation, if this is just represented as V, then that's my final velocity. If V naught and V are together, the V is my final velocity. So that's just something to consider at that time. So now I'm going to throw back the kicker. We talked about it in class the other day. There's a little g that goes along with all of this stuff. Really, anytime I talk about this subject, this always pops up into it. Now what is it? We talked about it in class the other day. I told you, you only have 9,996 more times you're going to hear it the rest of the year. That little g represents, you guessed it, gravity. Gravity is affected by everything on Earth. As long as we're on Earth, it's always the same. And that magic number just happens to be 9.81 meters per second squared. Okay? Remember, 9.81 meters per second squared. Regurgitate it. Put it in your notebooks. Highlight it. This is what we're going to use to represent gravity. Okay, gravity is measured in that way. So let's go through real quick and let's just throw out the unit of measurements. If I'm talking about velocity, an object is going a certain amount of speed in a certain amount of time. So if I look, my distance is always measured in meters, my time is in seconds, so my unit of measurement is meters per second. Okay? What's distance? I already told you. It's in meters. Time? I already told you. It's in what? Seconds. Right? Acceleration. I have a meter per second over a second. Okay, right? Velocity is measured in meters per second over a second. So, that is meters per second squared. Do you see a correlation? Meters per second squared, meters per second squared. So what does that tell me about gravity? That gravity is equal to acceleration. Remember that. That's going to be an important key later on. Gravity, acceleration, they're measured in the same units. So as an object is falling, that's telling me it's accelerating at a rate of 9.81 meters per second every second. Okay? There's a correlation there. We'll get into that later. Final velocity, meters per second. Initial velocity, meters per second. Measurements, keys, very important keys. Remember those. You're going to have to put them up here. You're going to have to be able to look and immediately tell, oh, that's a velocity. Oh, that's a distance. Oh, that's a time. Okay? This is just something to get us kicked off. Remember, kinematics formulas. Anytime I say kinematics in class, this is what you need to remember. Okay? These 4 formulas. Write them down, memorize them. I'll see you next time.